Swarms of drones are taking to the skies, promising to revolutionize everything from search and rescue to package delivery. But coordinating these aerial dancers poses unique challenges. How can we ensure these mechanical marvels work in harmony without colliding or losing their way? Enter Swarm LIO-2, a groundbreaking system that acts as the brain and nervous system for drone swarms. At its core, this innovation allows each drone to precisely know its position and the locations of its teammates, even in GPS-denied environments. It's like giving each drone a sixth sense, allowing them to navigate complex spaces with unprecedented accuracy. Imagine a group of blindfolded dancers performing an intricate routine. Now picture giving each dancer the ability to sense the exact movements of their partners, even without seeing them. That's what Swarm LIO-2 does for drones. This capability is crucial for enabling large-scale drone operations in challenging environments like dense forests or urban canyons. One of the most impressive features of Swarm LIO-2 is its ability to seamlessly integrate new drones into an existing swarm. Think of it as a well-choreographed flash mob where new dancers can join at any moment, instantly falling into step with the rest. This plug-and-play functionality opens up exciting possibilities for scaling drone operations on the fly. The system's robustness in the face of adversity is truly remarkable. Even when individual drones lose sight of each other or encounter areas with limited visual features, Swarm LIO-2 keeps the swarm coordinated. It's akin to a team of mountain climbers staying connected through a blizzard. The system provides an invisible tether that maintains formation. This resilience is vital for ensuring drone swarms can operate reliably in unpredictable real-world conditions. Perhaps most impressive is Swarm LIO-2's computational efficiency. As the number of drones in a swarm increases, the system's processing time grows at a surprisingly slow rate. In experiments with 40 drones, Swarm LIO-2 required only 9.13 milliseconds per update, a fraction of the time needed by previous systems. This scalability is key to unlocking the full potential of large drone swarms for complex missions. The implications of this technology stretch far beyond simple drone coordination. Swarm LIO-2 paves the way for autonomous aerial systems that can work together to tackle challenges once thought impossible. From rapidly mapping disaster zones to choreographing spectacular light shows, the possibilities are limited only by our imagination.